All right. I think we can start now. Good morning, everyone, and welcome back to the second day of voip. So, I'm Naba Kumar, working for real-time communication team. I have a project in Nokia. So, my talk is about integrated communication framework on the GNOME Desktop. Internet communication has become very important for us nowadays, and many of us cannot live without it anymore. There are normal users are also using it quite often. That means we have to take into account internet communication, a small utility that we use on our daily basis, but rather something that is very much part of our desktop that we use constantly. There are lots of user applications that provide network features that would require connecting to another computer, another application, and communicating, such as like normal internet-based games or internet-based services. But these services usually involve communicating with computers, not users. We have chatting, which we do in terms of users, not computers. So you talk to your friends, your family members. But there are other applications. When you set up a network connection to another application, it's about like connecting to a computer. You give some computer name and then it connects there. Then you have to set up something which is like not very user-friendly in a way. And then we have this infamous problem of too many ways to do the communication. We have several protocols now, and different services are inventing their own protocols, and users are in a way very confused. They have half of their friends in another using another service and another half using another service. They have to run like multiple clients to get around this problem. They are, well, clients which solve this problem by implementing all the protocols together in the same program, like famous game IM client. However, we want to look into something that would allow, let's say, everything on the desktop. That includes applications, IM clients, or your audio, video call application, all to work together in harmony. And that would require to look into a slightly different approach. So the first thing we need to consider is to make communication a service, not an application. So you don't start an application to do some communication. You get it already in your desktop. So it's completely part of what you are already doing on the desktop. So you get internet messaging as part of the service, and then you get this call handling as part of the service, any sort of notifications involving in it as part of the service, and not to mention other applications that are not really IM or voip specific to also take part in the same framework. So that, let's say, you can initiate a chess game with your friend, someone who is already online. Okay, so in this talk, we are going to look at the great Telepathy Framework. I'm going to give you an overview of the framework, but it's a big framework, and there are lots of things happening in it. Thanks to Collabora, it is now a very mature framework already. And then we look into a very important component in this framework called mission control, that controls all the traffic of communication for your applications. So we will look into what it is and how it works, what it means for applications and application developers, and what it can do for you. And then eventually we'll look into several user-led applications that can take advantage of mission control and what it provides. So let's first look at Telepathy Framework. So this is a framework which was designed to unify all existing communication methods into a single framework. It defines basically a unified set of interfaces, DBus interfaces particularly, and it is about just breaking down the whole IM and VoIP application into pieces, well, rather meaningful pieces, and then you can have independent development of these components. Then you can just put them together to work. This means that all the protocols are isolated from the rest of the implementations. You can create your own implementation of new protocol, just plug it in, and then the framework just lets it work with the rest of the system. For each protocol, we create a connection manager that manages all the connections related to that protocol. And it will do the real networking with the service, and then translate it into telepathy interfaces, which then the rest of the telepathy system will utilize. So essentially, all the components talk telepathy language in a way. And well, there are more in this, but this small diagram shows you the concept, how it works. So we have like different protocols, and they are implemented independently, utilizes telepathy interfaces, and then you have single unified interfaces that your applications can use. So we have several connection managers already working. The biggest one and the most mature one is Telepathy Gabble, that implements XMPP protocol to work with Jabber and Google Talk services. It can do almost all sorts of internet communication, chat, group chat, audio call, video call, and it also implements queues, which is used for application-specific data transfer, and it is a very mature connection manager already. Then we have IRC connection manager called Telepathy Idle, which is more or less functional, but not quite perfect yet, and there are still work going on to get this right. Another important connection manager is SOFA-SIP connection manager, which implements SIP protocol. It utilizes SOFA-SIP stack, which was created by Nokia. And so far we have basic peer-to-peer chat support and audio-video call. There are more features coming, like some advanced call handling things and conference calls also. Then there are some more connection managers mentioned there. Wilder, which implements AIM and ICQ protocol, and the Salute, that is link local protocol connection manager that allows you to work with your friends in the same local network. Then there is Telepathy Butterfly, which implements MSN protocol. So some of them are not very ready right now, but still work is going on. So let's come to Telepathy Mission Control component, which, as I already said, controls the traffic for your application that comes from Telepathy Framework. These are the things which it does in a small nutshell. So this is basically a service daemon that runs always in your desktop. Whenever you go online, the service is there and it monitors telepathy, connection managers, and any sort of events that's happening inside. It will take care of maintaining all the connections, and that's happening inside those connections, and what channels are currently active for all those connection managers. It will aggregate user presence and handle all sorts of notifications involved in trying to get the presences aggregated from different protocols when you have more than one protocol running. Then it listens for communication channels, so if there are any sessions, also handles accounts management for you. That means all the applications will be using the same accounts configuration that you set up for your internet services. Once you set them up, then every application that will utilize the framework will sincerely be using the same setup. And they can also get notifications on that. Now we'll go through all these one by one in details and see how mission control tackles them. This will also give you insight on what your application gains by not doing these things again. So we are trying to make a central place where we don't have to repeat the same things in every application. Now this is a very simplified view of an obligatory stack. We have connection managers in the lower level that interfaces with the network, that does the real talking with the server. Then we have the framework, Telepathy Framework, that combines all of them together in a set of unified interfaces. And mission control runs as a service and then controls the traffic for all the user interface applications that would be running on your desktop. So I have written just some basic user interface applications, but the idea is that you can have many more of them. Now again, this is a diagram which would show you how on the desktop the things would basically go. So the daemon basically keeps on running as you go online, and then all sorts of incoming events. There are channels created when you talk or when you call. They are all trafficked to the right application based on what they can handle. For example, Presence UI can run on your applet as a small applet, and then you can have the rest of the system not running. So you don't have to have a single instance of application running all the time. And then when you receive some event like a chat message from a friend, then mission control will ensure that you get chat UI started and then continue chatting. Similarly, there are, for example, you can see those cards. They are basically, I mean to say, like network-based games, or let's say a poker game. If you want to play a poker with a friend, then just right-click on your friend's contact and say invite a poker or something. Then you can just start playing poker. Well, perhaps we can also think about having Quake running that way, but that's a different story. Anyways, for context synchronization, EDS Sync does the job of making sure that your contexts in Evolution Data Server are synchronized properly with your...
Yeah, just put the fake thing here.
Yeah.
Is it suitable to send high bandwidth through tubes?
Not really, but well, I think if we really want to do it, then we can figure out something. Okay, so yeah, so EDS Sync basically takes care of making sure your contexts in Evolution Data Server are all synchronized properly, and if you remove or add new contexts, then you get them already reflected in your address book. Galago is a framework that maintains your context presence from different places, and then Telepathy Feed will feed the presence information to Galago framework. If your application uses Galago, then you automatically get this presence synchronization. Okay, so now let's see the first and foremost important thing mission control does is maintain the state of all your connections and channels. So each connection has several active channels depending on what you have currently running. You can have multiple chat sessions running, and you can have group chat running, an audio call running, for example. And these channels are all maintained inside mission control, and mission control makes sure that they are properly created and destroyed. And then it will then there is this presence management. Well, actually accounts management, but they are all the same. So when you go online, for example, it makes all your connection managers go online together, and then ensures that they made the right presences. And yes, and then these channels, they are mission control will make sure that the respective handlers or application user application are running to handle them. So this is a very simplified diagram of mission control and how the whole traffic thing goes through it. So we have a bunch of connection managers on one side. They are all created inside mission control and maintained. And then we have this presence UI which runs in your panel applet. And by some logical means, we try to make this unified presence to different connection managers, and then we set the right presence for them, for each of the protocols. And on the channel side, we have incoming channels, and these go through for a series of filters. That using filters, they can basically do a lot of things before the channel is actually handled, and eventually they will be dispatched to the respective user interfaces.
Are connection managers processes or plugins to mission control?
No, they are processes. They all work through device interfaces, so they are completely independent components. But filters are plugins. I'm going to talk about filters in later slides.
Are you going to talk about with the device interfaces before?
Not really, because the device interfaces for mission control.
Just all the.
No, that's part of Telepathy Framework, and it's like huge. You can actually already get the technical details about Telepathy interfaces, Telepathy website. I'm just trying to give how all of them are going to work together. Okay, user presence. So we have this presence UI that only takes care of your presence, and it has a single set of presence. That means you don't really set different presence for different connection managers. That does not make sense in a way. And then when you request a presence, mission control will take note of it and determine what the right presence would be for different protocols that you are currently running. You can set up multiple accounts for different protocols, and then, well, everything is like synchronized together. When mission control goes online, it will find all the accounts that you have configured and determine the right profile for that account, which I will again talk later. For each profile, it will again determine the right connection manager, and then it goes online to the connection manager. Yeah. And yeah, presence aggregation is a very simple concept of having a single set of presence and not to confuse the user with multiple presences that you can set to different accounts. And we try to synchronize back and forth between server and your user interface. Then, channel handling. So we have this Telepathy channels created when there are incoming new communications. Mission control will get notified of all the new channels created. They are basically then diverted to the right application. Now to do that, we need to have a system which is very similar to MIME type handling. For each channel we have a channel type, and channel type determines what sort of communication it is. Based on that, it will identify the right application. For that, the application has to install particular service details. We call them handler files. Then we install them in certain standard locations where mission control can find. Once the application do that, it does not have to be running to get the channels. And yeah, that's basically it.
Question on your
Yes.
channels. I'm not really sure why you brought channels all the way up into mission control, because they seem they're more application specific. You're tying an application to a channel. I can see the concept of filters, where that might be helpful, but it seems like that once I get the common connection, that me as an application, I want to handle the channel myself. Unless you're worried about
not running
applications
in the
not
first
cleaning
place.
up.
Well, as an application, you are not running at the time. When you get an incoming channel, mission control is the only thing running. And then, well, it obviously makes sense to make channels application specific. Well, it's up to you. If you want to handle 2 channels, that's fine. That's not a problem.
Right.
But if you just want to handle, let's say, chatting, or if you have a chess program where you embed a chatting window, then, I mean, you don't care about VoIP or presence, that kind of thing. So you just make sure that application is completely independent of the rest of the telepathy system. It just handles the channel.
So if there's 2 applications running that register for text on Gavel, how do you determine who's going to
Yeah,
get that?
that's one problem we still have to figure out. Firstly, because we don't yet have 2 applications that handle the same channel type. So we have right now per channel type 1 application, and eventually we will have to have some more details in the service handler description, which would identify these differences. However, if you request the channel, which is like the other way around, you don't get the channel, but you request it from the application, then you get it back. So it doesn't go to some other handler of the same channel type. So that is not a problem. That already works fine. But it's other way around. If someone initiates a chat, then we have ambiguity of whether this chat has to happen in a window or it goes to a chess program, for example. I think the point is that you don't do that straight away. You first utilize the tubes to initiate, just specific connection first, and then you do this chat session separately, and then it works. Well, that's so far the theory. Okay, that's it. We then continue to extend mission control. So how we can, I mean, obviously there will be applications that want to do different things. They want to do some application-specific things which are not necessarily general. So what they can do is they can extend some features of mission control by installing plugins. And we have 2 ways of extending it. The first is by installing filters. Filters are basically small modules that applications can install to intercept these incoming channels. When you get a channel, and then the channel is associated with channel type and also the direction, whether it's incoming or it's outgoing. Depending on that, you set up a set of filters, and then whenever these channels come, it will pass through these filters one by one. And all the filters have to pass successfully before the channel is diverted to the right handler. Now, in the filters, you can do many fancy things. I will give you a very simple example. When you have incoming channel, you don't really want to start the chat application straight away. You want to give some sort of notification in the panel, and then maybe you give some information about what is being sent. And if you want to continue talking, then you click on the notification, and then it passes the filter. But if you reject the thing, and then it just rejects the channel. Now, again, same thing happens when authorization request comes. For example, so if someone asks for authorization from you, it goes through the channel filters. You have one filter that handles authorization, and then the filter basically makes sure it handles it. So that kind of thing. Yeah, there are some examples already mentioned there. So you can also check for context validity, whether they are blocked or spam or things like that. And it can also be used to wake up your system and do some fancy things. It can also be used to log your messages and information. So applications can install these filters in two different ways. Initially we had only shared library way of installing it. You just build small modules based on some shared library API. And eventually we extended it to do also through debug. So that means your application does not have to create this filter separately. It can already have it within the application. This is useful when the filtering would happen, for example, when your application is already running, but it doesn't work if it is not running in the first place. In that case, I think the shared library plugin is about the only thing we can do.
Speaking of debug filters, does it bounce from the connection manager to your application back to the connection manager?
Sorry,
The machine control of your application and back to machine control. So one for the filter before he writes this back.
This debug one. Yes. The idea is that if you have the application running, then you can install this filter via debug. Now, from mission control's perspective, it does not make any difference between shared library version or debug version. So if it is, yeah, and it's not a very heavy installment. You just install filter once while it is running. This also means that you don't really have to install service files and explain the details statically. You can already do it dynamically. If some filters does not make sense in some context, then you just avoid installing it via debug. Okay, and there is another way of extending mission control. So, as I said, mission control is a service daemon that runs in your system. We provide the default implementation. However, if your platform, by platform I mean, let's say some another device that runs GNOME, require certain aspects of the server to be done, then you can actually derive the server itself. And then you can have your own server implementation if you use it in your platform. Another thing you can do with that is implement custom provisioning. So provisioning is a new feature we are introducing in mission control. I'm going to talk again a bit later about this. So if you want to implement custom provisioning for your services, then yes, you will have to write in the code. So this is another aspect of mission control. It will provide a centralized accounts management for everyone. So what it means is that you can have accounts creation or accounts editing application somewhere in control panel or in your preferences, like GNOME preferences, which is completely independent of your other applications which handles the channels. So you set up your account independently and everyone gets it. That's the point. So how it does is that there are 3 levels of things defined here. So one is managers, which is representation of connection managers that are currently installed in the system. These are defined by manager files installed by the connection managers, and mission control will scan them on startup and identify all the active connection managers that are present. Then each connection manager can have profiles. So you have, let's say, Jabber connection manager, XMPP connection manager. Then you have 2 profiles with Jabber and then Google Talk. And in each profile, you can define parameters that are specific to these profiles. And then in the next level, you actually define account. When you define account, you give the standard credentials and also define which service profile it is going to use. So once we tie up the account with service profile, then we have complete information of how to get the account to go online. Now, once these are defined, there are a bunch of notifications and operations that you can do from the application to the accounts. This means that it is when you do something like when you disable the account from one application, it is disabled everywhere. Everyone gets disabled. And if you go online from one place, it goes online everywhere. So we give a central place to manage them. Yes, you had a question from.
When you have this center account system, is it an API exposed to dbus and the applications provide their own UI, or do you give a UI that the applications consider having both? Yeah.
Okay, the story goes like this. We so far have C API only for handling accounts. However, we have planned to make it also into dbus API so that the application does not have to link explicitly with mission control library. Right now, if you want to use account management, then you have to link against mission control.
So there is no like center telepathy control now for accounts. It's always handled by the application.
You mean the user interface?
Yes.
No, right now there is, Telepathy has account creation user interface. It uses mission control, so it creates everything there, and all of your applications will get those accounts. That's not a problem. The only problem, what I'm trying to say, is that we have only C API right now, and and mission control is based on KDIP. So if you have some other KD application, for example, which may not want to link to KDIP.
But isn't it slightly wasteful to expect, an application to each reproduce the whole set up references dialog instead of having some central application that can do the account setup for you?
No. I think we want a central place to manage your accounts. Well, accounts here means your internet accounts, internet communication accounts like chat, call accounts. Why do you want that set up from different applications, for example?
I'm saying there should be a central application instead of each application.
Yeah, exactly. So there should be a central application.
Yeah, does that exist?
Well, as I said, Telepathy has it inside it.
So maybe here it is.
Yeah, we can have it at some point. We can have it in what was it? GNOME about where my GNOME something about me. So you just set up about you, and then everyone gets it. So we are not quite there, but it's quite fine. Okay.
Another question is there a way in telepathy where I can scope a connection that's private to my application so that other applications can't come tear it out from under me or change things?
Yeah, there is. Not quite, but it will be. So you are basically talking about binding connection manager protocol, connection manager straight to the user interface, and not actually taking advantage of the fact that your connection manager can still be used by other user interfaces.
Yeah, I mean there may be cases I want it to be shared, but there may be cases I want it private, and I don't want other applications getting my connection or taking it down from me.
Yeah, it will be there, and we are working on it. It's already partly working, but it's not completely tested or something like that. It will be there.
Can you not already do that just by bypassing mission control? Just using the connection managers directly? Because that's
yes. You can have an application without mission control.
So doesn't that do exactly that?
No, but the thing is, you want to use some of the things that mission control does for you, without, and we still be able to, bind your connection manager with your user interface. Otherwise, you pretty much replicate what mission control does for you.
Okay.
Like, accounts, for example, which is very much tied to this whole service thing. So we will provide a way.
Sorry?
Build a server, your connection.
Yeah, so. Okay.
So what about the storage of the account information? I mean, we have GNOME keyring and so on. Are we using those things for storage? Because
right now we store it in Gcon. Well, but yes, we are thinking to make it more secure by using GNOME keyring or something more secure.
What I've been looking is that the only thing I have in GNOME keyring is the wireless keys from network. I have a huge amount of accounts everywhere, but no, nothing is used for it.
Yeah, it will eventually use. So that's also part of things what we want to do. But right now we are focusing on some other important things, which I will mention later.
On a similar note, connection with Evolution Data Server, does it exist or it is just in the plans?
Okay, it exists on an 800 device. The story is that if Ross Burton is here, okay, the story is that Evolution Data Server will have to have dbus interfaces.
I guess it works with whatever.
Oh, really?
It works fine. The component is sourced and it's now sourced between Telepathy components.
Yeah, interesting.
The UI needs to know a bit, as in if you're adding or removing contacts, it needs to set flags you're saying and then you synchronize it. And I think that's being worked on this project.
Yeah, so what exactly is that, what exactly it needs is that it can already do the sync with EDS sync, but the evolution will need some modification to take into account. There are certain flags, certain retard fields which are created and deleted when synchronizing the account. So evolution will have to be fixed for that.
Yeah. Thank you.
So the answer is it already works on an 800 and it's well on the way on normal desktop Linux.
Yeah. Okay. Okay, another thing Mission Control can do for you is service provisioning. So this is, I'm sure many of you are already familiar with provisioning on mobile phones. So you get some sort of SMS from your service provider, and it does all sorts of setup for you. You don't have to go to singles. You don't have to set it up yourself. That Mission Control can do that for you. So if a service, not particularly Jabber for example, but some other service like SIP service, which require a bunch of things to set up, the users are really confused when they set up. Half the time it doesn't work, and it's because you missed some subdomain name in the real configuration or that kind of thing. So to avoid that, what it does is that the user only provides the provisioning credentials, one of which is a URL exposed by the service, and you can additionally take authentication parameters, but that's it. And when the account goes online, it will contact the service, and then it will get all the parameters necessary for that particular service, and then it sets up the account for you. It does it in theory all the time whenever you go online. But in practice, it's tricky because, well, first of all, it's unnecessary to do all the time. We should probably do it only once the first time, and then subsequently when it fails to do something, then you can provision and then it tries it again. And another problem is the service performance and how the provisioning actually works. Sometimes it could take several seconds, and you don't really like that thing happening all the time when you go online. So we will consider caching them for some time and then determine when to redo it again. The provisioning in Mission Control is a very general API. So what you do is that your service can have, you can have your specific implementation of the provisioning. first of all, we need to understand what we are getting through that URL. I mean, it could be anything. So that means we need different implementations. It could be an XML file describing the parameters. It could, be just a text file with key value things. That means you need different implementations for that. This is quite useful for SIP accounts. We are going to have this thing working for SIP first. As I mentioned, Telepathy software SIP provides SIP connection manager, and right now you have to set up, I don't know, something like 8 or 9 parameters for setting up your account. And that's just the basic one. If you involve a few more features, then you're setting up like 20, 25 settings. It's crazy. It can also be used for other services, just to simplify users' experience. For example, Google Talk it uses Jabber protocol. It uses Jabber XMPP protocol, but it has its the service settings slightly is different from the default one. So it has a different port and different things. So that can be avoided using provisioning. If Google provides a URL where you can download it, then the account just needs.
But isn't that why you created the Google Talk service profile?
Yes.
So would that be redundant then?
One thing is that profiles are static in the first place. So once you install it, it stays in the system. And this is a very dynamic thing. So the idea is to use provisioning for settings which are likely to be dynamic. And also consider SIP services, for example. You cannot have profiles for every SIP services. You can have some, let's say, default SIP service profile that takes the default parameters. But then if you have some foo bars SIP service, and well, it can sell you a Debian package and you can install the profile file there, but you know, it can also go through this provisioning way.
By the way, does there exist open standards for example, the XML file which provides those? I mean, is this going to be just hopeless if the providers don't actually follow the normal standard?
Yeah, that's something something that has been bothering me in first place. There is no standard yet, as I understand, and there are some efforts being done by big companies. I mean, Nokia is also part of it. They are like OMA provisioning service and other things. There are several companies also involved in this whole standardizing thing. The problem, as I see, is that it is still not completely working standard, and and they are another problem is that they are mostly geared towards cell phone provisioning. So we don't really yet have any sort of provisioning for internet communications. But I mean, what prevents us to start one? So. And Telepathy tubes. This is a new thing recently introduced in Telepathy. This is about letting applications exchange application-specific arbitrary data stream or those messages. So we have currently these two ways of sending messages. One is Libus messages and arbitrary streams like TCP. These will be used for really application-specific data transfer, like exchanging chess moves, for example, or in a poker game, some poker-specific moves. It is currently implemented in Babel Connection Manager and Solid Connection Manager for both single and multiple users. Yeah, practically, right now, it is used in all PC device to do AB versus collaborative write thing. So different children can just write together.
When you say you can send dbus messages, do you support the entire dbus type system over the internet?
Well, Robert can answer, yes.
Yeah.
How? It supports everything that doesn't use centralized busing.
You open a peer-to-peer connection with the connection manager, and then it serializes your messages however you want to.
So does
And
it
they
pull them out of
format
dbus and put it in its own serialization format?
Yeah, well at the moment we've got some of you base 64 and some of you are taking packs, so depending on where we go,
That's probably not good.
Yeah. So once, now, the reason why I'm mentioning it here is because we don't really have this support in mission control. So telepathy tubes is a channel type. So we need to handle it just like any other channel, and we right now do not do that. In future, we are going to implement this certain type of channel handling, and then that means we can also start using applications to use this feature. Apart from that, we are also considering to redesign the dbus interface for mission control. This interface hasn't changed from 0.1 version that we started. It just got stuck there, and for backward compatibility, we have been using the same thing. But apparently, we need to rewrite it, redefine it again. Yeah, and we also need to define accounts API using dbus interfaces. The reason is that right now, for some applications to use mission control, it requires linking to lib mission control. So it's not completely independent as it should be in the Telepathy Framework. Once we do these things, then mission control would be a fully independent Telepathy component that you can have any application to use, let's say, different mission control on KDE side, for example. Yeah, let's go through some of the applications, some interesting applications. I haven't mentioned many, but these are some of the interesting applications that would realize the kind of approach I just mentioned. So Empathy is a project being pursued by Xavier Klassen. I'm not sure if he is here. Hey. Okay, so it was originally planned to be done in Goship client, but eventually it was forked because the approach was different. And now it has most of the things already working for chat. You have context list, presence UI, notifications, account creations. And another interesting thing is that it will provide useful widgets library for applications. So that applications just embed the chat window there, and then you can just utilize chatting there or audio coding. And VoIP UI, which is missing right now, is under development as a summer of code project. Yeah. So if you want to know more about this thing, if you want to use certain widgets in your application, then, well, you know that device there. And for audio video call, we are going to use Stream Engine, which is another telepathy component that handles the media channels. It uses Farsight to create streaming sessions. Farsight basically does the pipeline creation for whole streaming. It will use GStreamer for the actual media processing. And therefore, it provides like RTP GStreamer plugin and a bunch of other plugins used for internet streaming. So, Philip is the guy if you want to know more about internet streaming using Farsight. Okay, for context, we already discussed about telepathy feed and EDS sync in the previous, this nice diagram. But here are the things what they do. Telepathy feed basically synchronizes telepathy presences with the Galago, then application using the Galago framework can use the presences. It also does the same thing for capability support. And EDS sync does the context synchronization with your Evolution data server. And it also binds all your context with your IAM account, so that when you start a particular action like chat or call or play chess, it knows which account to use with that context. So that kind of binding is handled there. It also takes care of synchronizing avatars with server and updating them whenever they change. And there are a few more other things that it handles.
I have a question about Galago stuff.
Yeah.
Does mission control effectively make Galago redundant? I mean,
No.
if it's handling all the presence itself.
Well, we are talking about users' presence. Mission control basically handles the account's presence. Galago probably also does that thing, but I don't really know if Galago can be used in this context. But in this thing, what it does is it synchronizes context presence. So it's not the account's part that it handles right now.
But what benefit do you get from requesting a contact's presence from Galago versus requesting it via mission control? How can you not do that?
First of all, you cannot request your context presence from mission control. It doesn't do anything.
Okay.
Unless you will have to implement a lot of other things to get it working. So those things are already done in telepathy feed. It just gets there, so you can use Galago with that. So, however, the story is that at some point these two will be combined, and Galago might be, well, I don't know, there's Jorgen. Yeah, so he's the guy who's doing all this stuff.
So, yeah, if you want to, let's talk about it later. I can explain how it works.
Yeah.
Question on your EDS sync. Does it
Can
bring down
I ask you guys maybe to keep the questions until later, because we're about to run over and it wouldn't be good or fair on the next speaker?
So, but there's just a couple of more slides. Okay, this is another interesting project that's right now going on. Silent is about people browser. So the concept is, if you have used N800, the concept is very similar to that. You have an address book where you have all your contexts synchronized. It will use Evolution data server, and then you can have actions associated with your context. So you just start the action from here. You don't bother going somewhere else. Okay. This project is being pursued by Travis Richter. I wonder if he's here. Hey. All right, so we are expecting a release soon.
Yeah.
Yeah. So this is a very interesting project and maybe something to try out. Now, telepathy is being heavily used on IMO right now, on an 800 device. So it has completely and fully working system. So everything I just mentioned is there. So we have like different components, and then mission control controlling the traffic, telepathy connection managers doing lots of things, accounts management, UI and control panel, things like that, and the RESTful database, which is Evolution data server. Again. Okay, and we have been working on improving our internet communication software on the device. We have few things to release. Eventually, after this talk, I'll make a release. Yeah. So the things. So this is a software update for N800, which will update the internet communication related components on it. You will get SIP connection manager on that. That is based on software SIP. It supports basic IM chat messages and call, video call. Video call is slightly buggy right now, but audio call works quite well. You can also call PSK numbers already on this. So, yeah, we are also going to do some demonstration over the Nokia Stove. If you are interested, you can come over there and I can show you a few things. Then there are several UI improvements to improve the usability and to make the device more useful in terms of being used as a phone-like thing. We have Google Talk Relay support implemented. This is going to make things easy when there are certain kind of
3 minutes.
Yeah.
3 minutes.
Yeah, this is the last, or almost the last slide. There's the URL. You can download it from there. These are some interesting links. If you are interested to know about things I have already mentioned there, then please visit these links. So that's about it. So if you, I don't think we have any time for questions. I have 2 minutes or 2.5 minutes, maybe. I can answer one question. Time for questions. I have 2 minutes or 2.5 minutes, maybe. I can answer one question. All right, no questions.